Welcome to Insight Builder channel. Python experts, PyTorch enthusiasts, and my dear friends. Exploring PyTorch on Raspberry Pi, hands-on tensor data manipulation for AI enthusiasts. Part 4 of multi-part series video. We had been discussing about how to do matrix multiplication, how to visualize matrix, and we also saw the basic introduction of how to work with various sizes of tensors in the last video. So we had been working on these series of commands. If you have not looked at the last video, do take a look at in this playlist, and you will be coming up to speed in no time. Now we are going to continue further. If also one more important thing, if you want to understand how to visualize matrix, you can take a look at the tool. You can get that information in the link of that tool in the description below. Let's go back to so yeah, this is the tool reference link, and also this is the tool by itself, so you can get that detail, etc. Let's continue. So in the last video we had tried to work with a single dimension, that is vector and two-dimensional matrix multiplication. Now we are going to take one step back and we are going to do a vector and vector matrix multiplication, that is single dimensional matrix multiplication. So you can see that there are many kinds of multiplication that we can do using this MatMul, and depending, so I'm going to do a copy of this, of all this option, and I'm going to paste it here, and I'm going to make it as comments. So the reason why I'm trying to do this is you can refer to this anytime you want, and I will also be placing it in the description also, YouTube description also. So if both the tensors are one dimensional, the dot product scalar is written. So I'm going to do that only. I'm going to take two one-dimensional matrix. That is, I'm going to take the matrix, where is the matrix? I'm going to take the matrix A, and I'm going to take the tensor that has been created using the rand function, that is B. So both are of size 3. You can see that here. So I'm going to take this and I'm going to say vector with MatMul. Okay, and I'm going to say torch MatMul, and I'm going to send in both the vectors, and I'm also going to print out the result, and you'll see it will be a scalar. So this is the scalar output that has come out. So if you take a look at the size of this tensor, you will see that it actually returns as a scalar. So if I do a MatMul on shape, you'll see that it doesn't have a size. So basically it's a scalar. So this is how you actually find out what is the scenario. Now next what you are going to do is, when both the arguments, meaning A and B, are two-dimensional. So we already have two-dimensional matrices. That is, we have C, which is a two-dimensional matrix, and we also have D. D is also a two-dimensional 3x3 matrix, and this matrix D has been created using random numbers. So that we are going to do now. So we are going to say matrix multiplication with MatMul, and we are going to use torch.matmul. So you can either use MatMul or you can simply call C at D. So this is also going to do the matrix multiplication, and you'll see that it goes through, and you can take a look at the MatMul result here. So this is the matrix multiplication result here. The mathematics and how the actual algorithm does the mathematics multiplication, I am not going to discuss here, but the idea here is that to get comfortable with the various sizes, shapes of the tensor matrices that you can create. As you saw here, we actually multiplied a fairly simple matrices like single dimension and two-dimensional matrix. But what if there is a three-dimensional matrix? What exactly happens when you are going to create a three-dimensional matrix inside torch or inside tensor. So let us create one to see exactly what happens. So in the past I had created the two-dimensional tensor here. So if you look at the earlier video, you can see that. But now what I'm going to do is I'm going to create a three-dimensional tensor. So how are we going to start with it? So I'm going to say E equal to torch.tensor. So this is the regular way. Now I am going to create a single, I'm going to create a 2 cross, just a minute. I'm going to create a 2 batch 3 row 3 column matrix. So basically I'm going to create 2 batch 3 row 3 column matrix. So meaning I need to first of all create a matrix which has 2 batches. So this square brackets here, the inner square brackets are going to be the batches. So this is going to be the batch 1 and this is going to be the batch 2. And inside the batch 1 I am going to create a 3 rows, and again inside the batch 2 I am also again going to create a 3 rows, and inside the 3 rows, inside the first row in batch 1 I am going to do 1 2 3, and here I am going to say 5 6 7, and here I am going to say 5 60 and 3. Now the first batch of the matrix is completed, and I'm going to start with the second batch. I'm going to make it as all tens right now, 97 65 23, and finally I'm going to create 5 62 and 35. Now we have created a 2 batch 3 row 3 column matrix. How are you going to find it out? We are going to actually name it as D type. We are going to give it a D type of torch dot float 32, and we are going to execute it, and it has got executed. And if you look at the shape or size of it, try to prefer size most often, and you'll see it is coming out as 2 3 3. So this is a 2 batch. The reason why I'm talking as 2 batch is because once you think about it as 2 batch, then let me go here and let me show you what I mean. So this is one 32 cross 24 matrix. Let me actually create a small matrix itself, so that will be easier. I'm going to go into the reference and I'm going to create a 3 cross 3 matrix for your visualization, and then I'm going to change the, I'm going to make it as 3 3, and I'm going to also make this as 3 3. Okay, and I'm going to reduce the gap here. Okay, I reduced the gap. So this is a 3 cross 3 matrix, right? So let me reduce the legend. And so this is a 3 column 3 row matrix, and if there are another one square, another one set of these elements in parallel to this, so here we are not seeing that. So I'm going to take a snip of this entire matrix so that you can we can actually visualize it better. So I have created a just a snip of it, and snip of one of the 3 cross 3 matrix. And if I am going to create one more, what will happen is, that is how it will get created. So there are 2 matrix 3 cross 3 matrices, and it will be together inside a single matrix. So that is how this particular matrix is getting created. To visualize this and understand what is going on is very important, because now assume that if you are going to do a matrix multiplication, how is the matrix multiplication going to happen? So let us try this with the 2 batches 3 cross 3 tensor. So we are going to do a matrix multiplication of uh, the the tensor E with the tensor C. So let me also print C for you guys to understand, I mean to visualize and look at the elements. I'm going to do F is equal to torch.matmul. I'm going to use matmul function so that you guys can see what are available. So here if it is saying if the first argument is two-dimensional, the second argument is one-dimensional, it's a matrix vector. If both the arguments are at least one-dimensional and at least one argument is n-dimensional, that is, this is one of the point. So this point, if both the arguments are at least one-dimensional. So in our case, let us actually fill up the arguments. So I'm going to do it with E and C. In our case, both the arguments are at least one dimensional. So E is of 2 cross 3 cross 3. It is three dimensional already. And at least one argument is greater than 3. So in our case, we have E is greater than 2. Sorry about that. And then a batched matrix multiply is returned. So this is what I was talking about. And this batched is why I am using this two batch, 3 row and 3 column. Once you think about the matrices as batches of two-dimensional matrices, then you will be able to visualize the stuff way more easily. If the first argument is one-dimensional, one is prepended, so this is similar to what happens here. And if the second argument is one-dimensional, one is prepended to it for the purpose of batch matrix multiply and removed after. The non-matrix, that is the batch dimension, are broadcasted. For example, if the input is j times 1, j times n, so the output is going to, I mean the output has been explained here, so it is better to take a look at the output itself. It's better rather than reading. So let us execute this. You saw that it got executed, and if you'll see right now that we sent in two batches of 3 rows and 3 column matrix, and we got an output of 2 batches of 3 rows 3 columns matrix. So let us do a shape, and you'll see that we got the output of 2 rows 3 columns 3 matrix. Why am I showing this, and why am I insisting on you guys to practice this is, once you start working with the data loaders, so in next couple of videos we'll start working on loading the data from various data sets, and we have to reshape the data so that we can feed it into the models. In PyTorch and in many of the machine learning, the models are actually just matrices, or models are basically created of numbers internally in shape of these matrices, and we are going to do matrix multiplication. There are lots of videos which discuss how to visualize matrix multiplication. As such, you can also use this tool that I showed, the tool that you see here. You can use this also to visualize. There is an animation that you can use to visualize that. Intuitively understanding what is going on is very, very important, and by such kind of practice that you are seeing here, it can be made more easier. The practice can be made more easier. I'm not telling that you understanding the entire neural network architecture or working with machine learning models is going to be easy. By this practice, your matrix multiplication and the rules that are used in matrix multiplication will get clear. Let us now do something little bit different. What we are going to do is we are going to take the 2 cross 3 cross 3 matrix, and we are going to multiply it with the vector. A vector is like this. So it's a single dimension tensor. Let us see what happens. So we know the matrix that we created, 2 batches of 3 row 3 column, that we are going to multiply with A. So let us say G equal to A at E, and we are going to print it out. You'll see that I don't know whether you expected this, but right there we see that we are getting a completely different output. We sent in 2 cross 3 cross 3 matrix along with the vector, and we are getting back a 2 row 3 column tensor. So what has happened here? Oh, excuse me. now this calls for a visualization. So you can try to do the visualization using this tool here. You can convert this into a single row, single vector, and you can see that output that we get is a single vector again. So this is going to be a single vector. If you're going to multiply with a 3 cross 3 matrix, you are going to get a single vector back. And if you are going to have 3 batches, so instead of having only one matrix here, if you are going to have one more matrix, then you will have one more vector output. So that is how you are getting this 2 cross 3 tensor output. Let's proceed. Next, what we are going to do is we are going to do a matrix multiplication on a vector and a vector. So let us see. A is a vector we already saw, and B is also a vector. So this is a B is also a vector. We are going to do a matrix multiplication on that. So you are going to use G, and we are going to say A at B, and you will see that it returns a scalar. So G, that will be returning a scalar. So this is a scalar. You can take a look at the shape of it. Next is where we are going to make the things much more interesting. There are two ways you can actually bring the tensors together. One is using the cat command, that is torch.cat, and another is torch.stack. The cat command actually concatenates. Basically, it it brings two matrices together, and it actually makes them one. But the stack, on the contrary, create batches. So when to use stack and when to use cat is something that can be a little confusing. But when you are trying to work with data sets, and if you want to create batches of matrices, then use stack. It is keep this in mind when you are trying to load. When you are trying to load the data for training, then use stack to prepare the data. Okay, in rest of the places where you are trying to do some kind of operations, like if you want to bring two pictures together or two different data together, then you can use cat. So let us see some examples. We already have some good deal of matrices and tensors with us. So let us first of all look at all the matrices and tensors with us. We have A, we have B, which is a single dimension tensor, or it's a vector. We have C and D, which is a two-dimensional tensor here. And we are going to now see how we can concatenate them and how we can stack them. Okay, so first and foremost, stack and cat also have their own rules. So you cannot just like that concatenate or stack the tensors which are not having similar kind of shapes and size. So what I mean to say is, so let us actually create H. So H is a new tensor that we are creating, and which is going to have just a single row with two columns. So I'm going to create 56 and 78. This is going to be a shape of one row, two column. To my surprise, I was wrong. I'm sorry about that. It is just a vector. It's not even one row. There is no one row here. If you have to create one row, then it has to be like this. It has to be enclosed inside the square brackets. If not, now you will get a shape of 1 cross 2. Once you enclose it with this square bracket. If the square bracket is not there, then it is a vector. This is one of the main things that I get tripped pretty often in case of NumPy, in case of PyTorch or SciPy. This is one of the major challenges that we face. So the shape that we are thinking that we are sending in is totally different from what we are getting, what we are already having. So assume now that this is a small matrix. It's a small vector that we are having only two elements. But what if we have a large number of elements? We cannot actually do like this, right? We cannot type it out. How to convert this kind of vector into a into two-dimensional matrix tensor. For that, we have something called as Unsqueeze. So if I run this H tensor, so let us actually create one more tensor. This time this is going to be a single dimensional tensor, so that single dimensional vector tensor, and I'm going to make it as 2380, and yeah, I will give it one more 79. And data type doesn't matter, you don't need to worry about it because we are not going to do any operations. So this is a single dimensional tensor, that is a vector, and what I'm going to do is I'm going to unsqueeze it. So that is a method called, that is a function called as unsqueeze. And once you use this function, if you ask, returns a new tensor with a dimension of size 1 inserted at the specified position. So what does this mean? So this particular input is the tensor that you're going to give, and the dimension that you're going to give has to be either 0 or 1, right? So this is a single dimension tensor like the one that we have, and I'm going to ask it to insert a dimension at 0. So let us do it. I'm going to ask it to insert the dimension at 0, and once I execute that, you'll see that, let me execute this. So you'll see that this square bracket got added by itself. So earlier I added this manually, right? But now if I use unsqueeze, it got added by itself. Now there is an opposite called as squeeze. So if I take the J tensor, okay, let us create a new tensor name, and if I take the J tensor and if I run it through squeeze, now what it will do is, you will see that again it takes an input dimension and returns a tensor with all specified dimension of input size 1 removed. So if there is a dimension of size 1, it removes it. It's as simple as that. So before we continue with this, let me look at the dimension of this J. So J tensor, if you see, there is a dimension of 1 here, and if I am going to unsqueeze this, then this 1 will vanish. So that's what the that's what this particular help tells. So let us run that, and I'm not going to give any kind of dimension here, and I'm going to execute the shape to see the output, and you'll see that as this particular squeeze help told that the 1 has been removed. So this can be useful in places where you want to convert the batches into vectors. So if you want to convert these things, you can use squeeze and unsqueeze. Try to practice this with little more bigger or multidimensional matrix. Now we have a multidimensional matrix with this. I think it is E. So we have this multidimensional matrix. The shape of this is 2, 3, 3. And if we try to do a squeeze on this, let us see what happens. So if I say HIJKL and I'm going to say torch.squeeze, and you will actually see that it's going to error out E, and I'm not going to give any dimensions here. And once so you can take a look at it here. If the tensor has a batch dimension of size 1, then squeeze will also remove the batch dimension, which can lead to unexpected errors. So keep this in mind. So if you're going to send the batched matrices, then it will remove that also. So it will not actually know. Other point is that if you scroll down, you will see that there are various options that they've already shown here, various examples, but this is a very different kind of an output that we are going to see. So, and once you execute the output, you'll see that it has not modified. So if you do the shape here, you'll see it is still 2, 3, 3. So basically, if it is not able to find a dimension with 1, squeeze will not do anything. And this can be a surprise. So you might think, okay, if I send 2, 3, 3 into squeeze, it will actually become 3, 3. No, it doesn't become. So this is something that I want you guys to understand. It has to be of dimension 1. Next, what we are going to do is we are going to go into concatenation. We were actually discussing about concatenation, but I diverted to squeeze and unsqueeze. Now let us jump into concatenation. Let us concat a comma b first. So let us take a and let us take b, and we are going to concat these. This is going to be pretty straightforward. So what we are going to do is we are going to say alm is equal to torch dot cat, and I am going to say that concatenates the given sequence. So we have to give a sequence of tensors. Basically, it should be, the tensor should be in a tuple or it should be a list, and then only it will work. If you give two tensors as arguments, it will not work. So you have to give a tuple like this, or you have to create a list like this. I'm going to create a comma b, and here you can actually provide the dimension. So you can, by default the dimension is 0, but you can actually modify the dimension to either 1, or if there is higher dimension you can include that also. As of now, I'm going to leave it blank, and I'm going to execute this. It will execute and see the output. This has concatenated and made it as a single long, it has made it, the columns have been increased here. It has been concatenated on the columns. Okay, so it has, now if you want to add, if you want to create another one row, how can we do that with cat? For that, you have to just change the dimension. So if you do the dimension equal to 1, then what will happen is you will see that there is a challenge now. So it is saying that the range can be either -1 or 0. So when you're going to work with a single dimension vectors like this, you cannot directly try to create multidimensional vectors out of it. Think about it. This is a single dimensional vector, and this is again a single dimensional vector. And if you're going to concat this two together, how it will get concatenated? So it has to become a two-dimensional 2-row 3-column vector, right? But cat cannot do that. For that, you have to use stack. So let us do the same thing that we did with with a and b, but this time we are going to do it with stack. Okay, and we are going to do it with dimension. First, initially we will do it without any dimensions and see what is output. You will see that by default it is actually creating a stack like this. So here, what we expected from this particular command, we got it from stack. And if you are going to do the stack on E and F, so you remember the multidimensional matrix, right? So we have E and F, and if you are going to do a stack on this, what do you think it will happen? So it is going to create batches of batches. This is where the things start growing out of hand. So assume that I am going to create n is equal to torch.stack, and I am going to send in this guys. I am going to send E comma F. I'm not going to change any dimensions because that is going to add on the batches directly. And I'm going to execute, and let us see the shape. Actually, the output is not going to make sense. You see that I gave a 2, 3, 3, and it added one more dimension or one more batch. Two batches of 3 cross 3. So you have to read it like that. So it's a 2 batches of 3 row 3 column matrices basically. So you see how the things are growing, and understanding how these stacks are working and how to unwind these stacks into when you're going to send it into the model for training, or when you're going to do an inference, can be a nightmare. So ensure that you don't cross the limit of 3 dimension. If you're going to go into the 4th dimension, you should know what you're doing. This is not actually a dimension. Basically, it becomes like an addition, or it becomes a additional square bracket. If you take a look at the output, you will see. So here you see the number of square brackets. It actually keeps on increasing, right? And if you are going to create a similar kind of 2 batches of 3 rows and 3 columns, you can see how to create it. So there is going to be 2 batches. This is the first 2 batch, right? And then comes the second 2 batches, right? So here itself you see how much it can get complicated, and visualizing this can become a tough job. So until unless you practice it pretty often, it's not going to be easy. So you have to practice this often, try to create the matrices like this, and then you will be able to properly manipulate the matrices, not by just looking at the videos or not by just looking at the working at the samples. You are not gonna, it's not gonna cut it. So you have to create the matrices, you have to see how the output is. You can see that there is four squares here, so that is square brackets here, and here there is 4 square brackets. So that is how you have created a two batches of 3 cross 3 matrices, 3 rows and 3 column matrices. Inside whatever the numbers that you are going to get, it doesn't matter. Why I am telling you these things is, assume that now I am going to create a torch tensor. O is equal to torch dot rand, and I am going to give a shape that is 2 cross 2 cross 2 cross 3 cross 3, and this is going to create a similar kind of a matrix, and it is going to be created from random numbers, and I'm going to print it out also. So I had to do a lot of work here. I had to actually do a lot of typing. I had to do a lot of additional checking whether I've done the proper pairing. But torch uses a simple method, simple function called as rand, and it gives me the output in no time. And if I am going to use torch dot once, and here if I am going to give a shape of 4, so you will see that it is giving me immediately a single vector. And again, if I change it and if I give a shape of 4 comma 3, it's going to give me this. And if I am going to give a 4 comma 3 comma 3, so this is giving me a batch of 3 cross 3 matrices. And now the things start interesting. So there are multiple ways of creating such batches inside torch. But the point, as I was telling you, is that how will you manipulate it? So we saw that we can use stack and cat, and there are various ways you can actually batch. You can work with batches of matrices, and we also saw how to visualize each and every step of doing the matrix multiplication with vectors to matrices, vectors with vectors, matrices with matrices. We saw all those things, and we also used this particular tool to get an intuition of what is going on in this particular video. So continue in this lieu of practice and see where it goes. After a considerable amount of time being spent on this, then only move to the next presentation where we start discussing further on stacks and cats again, and also then we start slowly moving into operating on these matrices, and then start training with the data sets. So with that said, I would like to leave this video with 4 words, that is practice, 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 practice. See you guys. Have a great time.